there is one unit length that we can choose that gives us a unique relationship between these two graphs. You notice that the graphs of the unlabeled cosecant and sine functions meet at 4 points for every period of the sine function. There is one unique unit length that we can choose where they meet at only 2 points, and that is where the unit length is equal to the maximum vertical value of the sine function. I didn't have time, actually maybe I do have room to make that specific. The maximum vertical value of the sine, okay? Didn't have room to write in value, but you understand that occurs here, and it also occurs here, this point and this point. If we do this, then the graph looks like this, and I'm going to just leave it to you to prove this. Okay, the graph will, well, let's draw the vertical asymptotes. That's kind of an important thing to do, okay? Otherwise, we don't get a very good picture. Probably don't have one now either, but the graphs look like this, where they meet here and here. Now everything's a little bit askew, bad angle with the board, unable to draw it as accurately as I'd like. The point where this graph meets its takes its maximum values, of course, the point where it levels off, and it should be symmetric about a line through this point, as this should be about a line through this point. So I didn't get the symmetry quite right, but you get the idea. So correcting for symmetry and correcting for the shape of the graph, this is what happens if your unit length is equal to this length. And you should do that construction yourself and actually prove that. Prove that the vertical legs that you get to represent the y values of the cosecant function will always be longer, or at least as long, as the segments that you use to represent the y values of the sine function.